Hey, welcome back to RamZland. Today we're going to talk a little bit about centripetal force and the apparent centrifugal force experienced by an object. Check it out. All you need to illustrate centripetal and centrifugal force is a straw, a couple clear cups, some ping pong balls, and some tape. Start out by taking a few pieces of tape and connecting your cups together. Finally, you want your design to look something like this. You've got the straw and the cups. And this is where you can illustrate the difference between centripetal and apparent centrifugal force. So when I spin the cups, notice that the balls go to the outside. When I stop spinning them, they go back together. If I spin it, the balls want to move to the outside. That's apparent centrifugal force. That's from the point of view of the objects that are in rotation. Centripetal force is the force exerted by the straw causing the rotation itself, okay? Centrifugal force is really a fictitious force. It's the reaction of the centripetal force. That's the perspective of the mass that's in rotation. So from the perspective of the ping pong balls, they're reacting to centripetal force by moving to the outside of the cups. So in reality, centrifugal force is just inertia because every object wants to travel in a straight line. But instead of saying it's the lack of centripetal force, we use the fictitious idea of centrifugal force, which is really not a force. It's just an object's inertia. It also illustrates Newton's third law of motion that says every action has an opposite and equal reaction. So centrifugal apparent force is really an object's reaction to the centripetal force. So centripetal is center-seeking. An example would be Earth's gravity is the centripetal force that causes the moon to go around our Earth in an orbit. So remember, centripetal force is mass times velocity squared divided by the radius of the rotation. I hope you enjoyed today's edition of RamZland, and I'll see you next time.